Chester Chen. I'm the organizer for San Francisco Big Analytics. Our meetups, it's a basically volunteer based, and we're hosting all kind of talks like this, talking from the big data, about the databases, analytics, machine learning platforms, infrastructures, data infrastructures, visualizations, and so kind of cover the whole data end to end. So we depends on the topics. We just talking different deep. So this is a technical meetups, and so basically not focus on anything related to business, purely technology. So today we get some guests from Peter Pan, who's coming from the StarRocks, and they have an interesting topic related to the analytic databases in particular. There's the people already know ClickHouse, Druid, and Trino. So they claim of course they have outperformed all these their numbers. So want to give a little deep dive into how they did it and what's the technology. And StarRocks is also open source, I assume, Peter?
Yep.
Yeah, so it's open source. So I guess you can see the source code. Our guest speaker is Peter Pan. Is a solution architect at StarRocks, and he has a lot of experience in this area. So without further ado, Peter, take over, please.
Oh, thank you. Thank you for your introduction. Hello, everyone. Welcome to the meeting today. In this talk, I'm going to introduce our next generation sub-second MPP database, StarRocks. StarRocks has blazing fast speed as a killer feature. You can get most of your query result within 1 second. You can use StarRocks in real-time analytics, and the StarRocks is super easy to use and maintain. Of course, it's very cost-effective of your company. In the rest of the meeting, I'm going to go through each of the items below, drive you guys into the details of the OLAP industry and the StarRocks. First, let's review some new trends in analytics industry today. Those new trends leading the new requirements. Then I will show you our powerful solution for new requirements. You can see the benchmark comparison between StarRocks and other competitors. I will share the key technologies of StarRocks with you and share some use case as well. I hope you can enjoy the meeting today. In the recent year, we keep monitor the market and found some new interesting needs of the business. One trend is that the customer no longer to be satisfied with predefined reporting and limited dashboard. More and more companies want to empower their customer with the capability of doing sophisticated analytics on their own data. For example, self-service BI reporting, customer can build their own dashboard, real-time reporting, which can get the latest information by themselves. Those kind of new data product can help customer generate a special insight and make better decision. Another trend is data-driven, has become a top priority for modern companies to help employees do their operational jobs better. The front-end staff need flexible data analytics. They want to run complex and interactive queries. They want to refine the business metrics every week. They don't want the engineer team tell them the data requirements cannot be fulfilled. Operational analytics can help to detect business signals, extend or acquire knowledge and feedback, reduce performance risk, waste, and cost. At last, both for user-facing analytics and operational analytics above, intensively increased the number of people who are involved in the data analytics. We need to control the corresponding cost, which means we need to extremely low cost for every user. It's a bit pity that the old-fashioned product cannot meet the new requirements that come with those new scenario. Let's check it out. At first, user-facing analytics and operational analytics call for sub-second query latency. However, the old-fashioned products often need more than 10 seconds to get the result return. Second, the new scenario of data analytics require a flexible way to conduct data modeling, and sometimes the historical data in the data lakes are needed. However, the old-fashioned products rely on a pre-computing and a single wide table. Data lakes cannot be involved in analytics. Third, when doing real-time analytics, the old-fashioned products cannot support data updates. During the ingestion, the query performance could be very low. Fourth, high concurrency queries cannot be supported by the old-fashioned product. If there are more than 100 users query the data in the same time, many of them will fail. Last but not least, the old-fashioned product cannot be considered as cost-effective one because it's hard to control the total cost when using them. So the question here is how to meet the new requirements. My answer is StarRocks, the next generation sub-second MPP database. StarRocks is blazing fast for almost all kinds of OLAP queries, not just for single table queries, but also for multi-table queries. Especially in the multi-table query scenario, StarRocks is the best one. StarRocks is super easy to use. It supports standard SQL. You can do data modeling in star schema or Snowflake schema with StarRocks. The data in the data lake can be easily queried from StarRocks directly. StarRocks can support real-time updates. For the scenario in which data need to be updated, StarRocks is the best choice. For example, the e-commercial orders, the status of order may be changed at any time. Also, StarRocks can support up to 10,000 concurrent queries per second in user-facing scenario with a simple sharding model. As a result, by using StarRocks, you can cut 80% cost with even better performance. How fast can StarRocks to be? I think the benchmark can be the best way to tell you the truth. I will show the result of two benchmark here. One is SSB benchmark. We use it to test the query performance on a single flat table. Another one is TPCH benchmark. We use it to test the query performance for multi-table. As you may know, the single flat table is not friendly for real-time data freshness. Any data update, you have to rebuild the whole table and backfill data again. But still have a lot of company in this market still using this way. Also, the multi-table data ingestion and the join in real time is pretty important for some scenario like fraud detection, stock price analysis. So we did comparison with both SSD and TPCH. StarRocks is winning in all of them. In the SSB benchmark testing, we compared StarRocks with ClickHouse and Apache Druid. When running SSB benchmark testing with ClickHouse, we just followed the test guideline on their homepage about how to run SSB benchmark. We can find the StarRocks is faster than ClickHouse 1.7 times, faster than Apache Druid 2.2 times. If enable StarRocks bitmap index and cache, then faster than ClickHouse 2.2 times, faster than Apache Druid 2.9 times. In some specific but common scenario, like low cardinality scenario, StarRocks run even more faster. In the TPCH benchmark testing, we compared StarRocks with Trino because ClickHouse and Druid are not good at multi-table join, so we didn't bring them in. We run StarRocks in two mode. In the first mode, we load the data into StarRocks. In the second mode, StarRocks query data in half, just like what Trino did. You can find that StarRocks can beat Trino in both running mode. If you load data into StarRocks, you can get much better performance, which is about 15 times faster than Trino. Why the performance of StarRocks can be so outstanding? Here is the highlight of our core technology. When a query comes in, it will go through each of the stages. SQL parser analysis, logic plan tree rewrite, CPU engine optimizer, generate the physical distributed execution plan, concurrency control, pipeline scheduling, operator execution, predicates push down, index aggregation, filter, scan, join, vectorized column, storage engine. Finally, the query will be in touch and get the data return. In each of the query life stage, StarRocks did a lot of effort on it. like use CPU optimizer to generate and choose the best execution plan, use the partition and bucket to provide data distributed storage for high concurrency support, lots of different kinds of index, filter, aggregation, shuffle join, collocate join to reduce the data scan and data transfer. In the next couple of pages, I will go through each of them to see more detail. This is the architecture of our system, and there is no single point. FE stands as front end, which is responsible for operating metadata, SQL analysis, generate query plan, distribute execution fragments. All the FEs can respond to client's request, and every FE have a complete copy of metadata. Single FE fails will not affect the availability of the whole system. BE stands as backend, which is responsible for data storage and query execution. The data stored in BE is columnar. A table will be split into many tablets and distributed in several BE. The default number of replica of the tablet is 3. If a BE was down, the table in the BE would be transferred to another BE. StarRocks is compatible with MyCircle protocol, so all the clients that support MyCircle can connect it to StarRocks without any extra effort. In multi-table join query, in addition to execution engine, optimize the execution plan can also play as an essential role when improving the query performance. Because of the cost between the best plan and the random choice could be in order of magnitude different. The most table in multi-table join use, the more execution plan CPU engine will generate. As a result, it's an NP-hard problem for CPU engine to choose the optimal execution plan. Only an excellent CPU engine can select the relatively optimal query plan to achieve the ultimate performance in multi-table analysis. StarRocks has designed and implemented a brand new cost-based optimizer from scratch. This kind of optimizer is similar to Cascades. It's customized according to StarRocks' full vectorized engine and has made several improvements and innovations. The optimizer helps to reuse CTE, rewrite subqueries, perform lateral join, support join reorder, select the distributed execution plan for multi-join query, build dictionary to convert low cardinality string column into integer columns. At present, the CBO is able to optimize a set of 99 queries in the TPCH testing. This new CBO engine allows StarRocks to fully exploit the advantages of native vectorized engine. Compared with other similar OLAP database, StarRocks has more excellent performance in multi-table join queries, especially in the complex queries. StarRocks use partitioning followed by bucketing to support 2 types of data distribution, range distribution and hash distribution. In real-world scenario, the timeline of the data is important. New partitions need to be created and expired partitions need to be deleted. StarRocks dynamic partitioning mechanism enable partition rollover, can provide time to live management to automatically add or delete partitions. StarRocks use the hash algorithm as the bucketing algorithm. Within the same partition, data with the same bucket key form tablets. Tablet replica are physically managed by separate local storage engine. Data import and query take place in tablet replicas. Tablets are the basic unit of data balancing and recovery. Why StarRocks can do multi-table join in real time so fast? This picture here, I will explain one of the reasons, because StarRocks can do different kind of distributed data join across different storage nodes. StarRocks will optimize the join tab based on the data statics. Shuffle join will hash the data to specific node rather than do a full network broadcasting. It will significantly reduce the data network transfer size and save more time. The collocate join utilize the local data replica to avoid any network data transfer. Only do the data join locally. It's really useful when you do some large table join. Those kind of distributed data join is helping our client to restructure their data import pipeline. No need to do any denormalized white table anymore. The data import and ETL process become super simple because of the real-time multi-table join. The native vectorized execution engine allows StarRocks to fully utilize the processing power of the CPU. More specifically, native vectorized execution support column-oriented data management and processing. As a result, this kind of engine allows StarRocks to store data, organize in memory data, and run SQL operator by columns. In this way, column-oriented data management make effective use of CPU cache. It creates fewer virtual function and selection statements, which will improve the efficiency of pipeline in the CPU. On the other hand, the native vectorized engine make full use of SIMD instructions in the CPU. This allows StarRocks to function with fewer instructions. It's confirmed by our standard benchmark testing. The StarRocks native vectorized engine can improve the overall performance by 3 to 10 times when implementing operators. The vectorized engine provides StarRocks with the technology of operations on encoded data when implementing operators. Thus, StarRocks can implement operators on encoded string without decoding, such as join operator, aggregate operator, and expression operator. This can greatly reduce the complexity of SQL computation during the execution and increase query speed by more than 2 times. FE MPP engine generate plan and split into fragments, determine instance number per fragment, delivery fragment instance to the BE. Then BE execute fragment instance in BE execute the fragment instance. The old 1 thread per fragment instance mode will block the operation because threads suspending, like wait for the disk IO, wait for RPC response, and frequent context switch impose a penalty on performance. Big query eat up more CPU costs and small query are starved. How to scheduling task more efficiently? StarRocks developed a new pipeline execution engine. It can cooperate with our MPP and the vectorized engine to speed up the query evaluation. A pipeline is surpassed in plan tree. A physical plan can be decomposed into pipelines. Data dependency exists if 2 pipelines shared a joint. Straightforward to dictate state by running, ready, and blocked. Operators can be parallel and asynchronized execute. User mode task run as core routine. After a driver run for a time slash normally 100 ms or 100 chunks transferred. If it's still not blocked, the driver will set it to ready and yield the CPU to another ready driver. Blocked driver are set to ready after they are unblocked. Execution threads pick up ready drivers to execute and set their state to running. No chunk can be transferred into 2 adjusted operators. Running filters take effects on operators and the storage engine to reduce the disk IO, reduce the network transport, reduce import rows of the computation, use wait-free or lock-free algorithm inside of the STD mutex would improve the CPU utility. Intelligent materialized view provided by StarRocks can generate pre-aggregated table to speed up the aggregate queries. StarRocks provide real-time materialized view compared with the non-real-time one, which need to be refreshed manually in the OLAP database. In the other OLAP database, StarRocks real-time materialized view are automatically updated with changes which made to the base tables. Also, StarRocks automatically select a suitable materialized view to accelerate queries. when StarRocks conduct query planning, it will rewrite query to fetch results from appropriate materialized views in order to increase the speed of the query. StarRocks materialized view can be created and deleted flexibly. User don't need to build materialized view at once when base table are created. Instead, StarRocks allow user to determine when it should be create or delete after the base table or before base table. So also, when StarRocks create the intelligent materialized view, it will be automatically optimized at the background. The primary key mode has a better support for the real-time and the frequent updates. And ingestion is always a collection of absurd or delayed operations. The problem is how to quickly find the latest version of data after an absurd and delayed operation occurred. The mechanism StarRocks use is delete and the insert. Put it in a simple way, when ingest occur, StarRocks will find the location of all rows involved in absurd and delayed operation, use a primary key index, mark them as deleted. The deletion information is recorded in a bitmap file. Append the new data directly, update the metadata, and when query happens, StarRocks will quickly skip all the data marked as deleted and get the latest version of the data. In this way, we can guarantee the query speed. There are lots of details in design, like how to handle the compaction, how to handle conflicts in concurrent ingestion, how to design the primary key index so it can be looked up quickly. You can find more details in our document website. The primary key mode is suitable for real-time data updates, especially for scenario in which data need to be synchronized from MyCircle or other OLTP database to StarRocks. You don't have to build denormalized white table anymore. The primary key account for only a small portion of the entire data, and the memory overhead is pretty low. StarRocks provides real-time data service, ingesting data at second level latency. During the data ingestion, StarRocks storage engine guarantee the automaticity, consistency, isolation, and durability properties of each transaction, which you know as ACID. For example, automaticity means the transaction of the ingest of a bunch of the data is all or nothing. That means the ingestion must either fully happen or not happen at all. Isolation means that concurrent transactions in StarRocks will not affect each other. StarRocks adapts snapshot isolation to ensure that all reads made in a transaction by another user and systems will see a consistent snapshot of the database. Also, the resource group feature will help to isolate big queries and small queries. StarRocks provides efficient way to update data such as absurd mode and append mode. Absurd mode can be implemented by using several methods like delete and insert is the most efficient one. The method delete and insert use the primary index and secondary index to avoid sort and merge operations in order to quickly filter large amount of data. So it's possible to guarantee extremely fast query performance in database with large numbers of updates. Compared with before and after the real-time ingestion pipeline, you can see using StarRocks will greatly reduce architecture complexity. The Flink CDC is another real-time ingestion tool which can be used to ingest an update from OLTP database like MyCircle to StarRocks. The ingested data can be queried immediately. Here's some other easy to use features of StarRocks, like the standard SQL support, flexible data modeling, query federation, integration with a different BI system, elastic scalability with just a one click of the management dashboard. So here is the conclusion. of why StarRocks can do such good performance than other products. We use CBO optimizer to generate and choose the best execution plan. Use MPP and the pipeline engine to maximum the parallel possibility. Use column storage engine and vectorized engine will speed up the data load and the computation process. Prefix index, zoom map index, bitmap index, Bloom filter index, materialization filters, and the predicates pushdown can help to find the data more quickly and reduce the data scan size. Low cardinality directories, these are direction, will convert string into int to achieve much better search performance. Partition and bucket design can support high concurrency query, balance the data between each node. Primary key mode can support real-time ingestion and real-time update. Working with different data modeling like star schema, snowflake schema will help to simplify the data import process. Shuffle join, collocate join, and aggregations will significantly reduce the data broadcasting size between different nodes. Based on those kind of core technologies, StarRocks can provide much better performance than other products. Here's the demo time. I will show you 4 different demos. The first one is the web management portal. Another one is the deploying tool. And then I will show how to use StarRocks with Kafka message queue to do a real-time dashboard. And the last one is how to use Flink CDC to consume the MySQL bin log and real-time ingest into StarRocks. Okay, let's start the first one. So this is our user dashboard. You can just input your username and password and log in. So this is the dashboard we provide for our client, commercial client. So in the first page, you can see like how many storage you use, how many memory you use, and how many B and FE node, and also some monitor metrics here. In the second tab, database, you can see which database you have and what is the size. If you click one of them, you can see what is the table size, and if you click any table name, you can see how we distributed the data by bucketing and the partition, and how we distribute the tablets into different nodes. So in the cluster, you can monitor some metrics like the CPU, memory, disk from the cluster, and also you can use the alarm tab to build up yourself alarms based on those kind of monitor metrics. So nodes tab will show you current status of all nodes like the FE, BE, and you can use the scale up. You can use the scale up button to change the cluster size, also change the configurations and view the current variables, runtime variables as well. So query tab it will show you the most recent queries. If you click any query ID, it will open another window. Sorry, and the editor tab will show you the SQL command editors, and if you look at the left side, you can search different database and the different tables. If you click the table name, it will show you at the bottom what is the descriptions. Here I'm gonna show some SQL queries, which is from TPCH query 17. At first, let's query the counts to see how many data records inside the database. Here you can see we have about 540 million records inside this table, the line item table, and let's set the parallel fragment execution instance numbers to 8, which will calculate based on your CPU and cores what's the cluster size, and will give you the better execution parallel performance. And we can set the report success to true, which will generate some profile to help you to analyze the details of your query. So let's run the query first. So this query will use two tables. One is line table, one is part, which is from the TPCH database. And we will do some filters like which brand we're using, which container. And finally, we use a subquery to calculate the average number of the line item quantities. So let's run the query first. So as you can see, the execution time is here and the status is here. If you click the oh, it looks like not able to let me. Okay, not able to let me click the ID. Not sure what's the reason. Copy. No. Okay. Maybe I can show you next time. So here is the if you click the query ID, it will open another tab to show you the query profile and to show some virtual logic trees to figure out what's the predicate push down, what's the table size, and how to generate the hash table to do the broadcasting, and if there's any locality dictionaries generate for the optimization, and how many numbers after the input, how many the runtime filters can reduce the data size like that. So yeah, it's a pity not able to show this today. That's fine. Let's continue some other demos. Here is our deployment tool. We've already open sourced this deployment tool in the GitHub, so you can download and testing. And also we have the documentation to help you to step by step to use these tools. So as you can see here, you can just use some one-line command line to deploy the whole cluster. It will based on the configuration you write, like which IP should be the FE, which IP should be the BE, and it will generate the metadata, deploy DIR, and download the binary package and install everything for you. So it will check the authentication, check the HTTP port. After the check, it will start to do the deployment. And after the deployment, you can use the command like the cluster list and display the cluster to show the current status. This is the full picture of StarRocks data load architecture. As you can see, you can use Flink, Kafka to import data streamly or benchly from variety of data source based on stream load, routine load, and broker load API, which provided by StarRocks. Also, you can use external table to query data from data source directly without any data ingestion, which is very useful when proof of the concept. And after that, you can use insert into select to import the data from external table into StarRocks. Here's another demo I made. Use some shell script to generate logs and push the log data into Kafka message queue. And I write some Spark program which will pull the data from message queue and do some time string convert, and finally use the StarRocks stream load API, upload the data into StarRocks in real time. And the tablet BI system will create a live connection between the StarRocks and tablet. So it will be able to do the real-time dashboard in tablet. So at the bottom, you can see the table structure I'm using and some demo data, simple data. You can see the user ID, the set URL, time is the timestamp, and the code part of my Spark coding, which will convert the timestamp into some time string. Also, I use alert table command to create some materialized view. So you can see if you use different selected SQL command, it will go to different materialized view to optimize your query. Another demo is I use some Python script to generate to upload some real-time stock price data into my circle. So you can, as you can see at the bottom, my circle table structure is here. It's using 4 different tables and connect each other, and I use Flink CDC connector to consume the MySQL bin log, and use Flink connector StarRocks to upload the bin log into StarRocks in real time. The StarRocks migration tool is helping us to generate the MySQL table structure and sync the table structure into StarRocks. So finally, it will use some Python UI script to pull the data from StarRocks and display in the UI at real time. So at the bottom, you can see the select queries, which I use it to do the table join, multi-table join. It's a kind of complex join, multi-table complex join we use to show our performance. So here's another cool feature StarRocks can bring to our clients, which is significantly reduce the cost, about 50% to 80%. Because we're using columnar storage, so it's more efficient for data compaction, save more storage space. Because of the high performance, so it's used less computing resource, save more CPU. Because of single system for all, not really on any other third-party component, no data redundancy. So the learning cost of the learning cost is pretty low. So because the easy infrastructure and easy to use, so the maintain cost is pretty low. Because no need to rely on large flat tables, good support for static schema and the Snowflake schema. So modeling costs are generally greatly reduced. Requirements of development time reduced from 2 weeks to just half a day. The above information is all come back from our real customer feedback. StarRocks is sales available on GitHub since September last year. We have got 2,500 starts, about 500 folks, and weekly merged PIs around 110. Most of our clients are deeply involved into our open community, like Tencent, Trip.com. All of them are helping us to keep improve of our product. Here, I'm going to show you some of our clients, why they choose us and migrate from other of the competitors to StarRocks. This is the DD and Trip.com. They were using ClickHouse because ClickHouse has splitting fast analysis in flat tables, but the ClickHouse doesn't have the feature like support for the multi-table joins, doesn't support for high concurrency, not compatible for SQL, and huge learning cost and huge operation cost. So StarRocks do all of these things better. And the next one is the Airbnb and WeChat and Xiaomi. They were using Druid, but they migrate to StarRocks finally because Druid doesn't support ad hoc queries, doesn't support the multi-table joins, do not support real-time updates. Here I built a table to show you which is our competitors and what is their pain point and what is the key features of StarRocks can provide, and finally show you which user is our client migrate from the competitors to our product. So for the use case, the Airbnb tablet dashboard is built for internal and external user based on tablet BI reporting tool. It's need a quick response for user interactive queries and high concurrency support. Before StarRocks, they were using Presto. The query latency is normally less than 10 minutes, which is unacceptable. No one can wait that long for a UI request. After they moved to StarRocks, the query latency down to second level, normally less than 10 seconds for each query. They give us an example of their production query. Use 3 tables. One table is 500 million rows, one is 6 billion rows, and one is 100 million rows. Do 4 joins, 3 distinct count, and JSON function registers at the same time. The response time of these complex queries is just 3.6 seconds. This is excellent performance. Really help our customer to give their customers a smooth BI reporting experience. Minerva system in Airbnb is served for whole company metrics using. So it's not a single system, it's for the whole Airbnb company. They have 12,000 metrics and 4,000 dimensions used for various data consumption scenario like A/B testing, data exploration, and data analysis. Before StarRocks, they use muti-table, which need to be built based on thousands of metrics. And if any small change happen, they have to do data backfill and rebuild table again. That wastes a huge amount of computing resource. The StarRocks solution for them is on the flat join. Every time the data ingestion just go into each metrics and the dimension table directly, the real-time muti-table join will be queried from the client side, which means no need for denormalize the white table anymore. The data ingestion and the ETL process becomes really simple. The Airbnb Trust Analytics system is a real-time security system used in scenarios like fraud detection, attack detection. It's need to support ad hoc queries and real-time updates for the data science team. They will generate different rules and send the query to the system to find out if there is any security issue happening. Before StarRocks, they cannot build a system like this because of the real-time ingestion, real-time update, and the ad hoc queries be satisfied at the same time. It's really hard to achieve. Based on the StarRocks solution, they finally can build the system and make it online. That will extremely go through Kafka into StarRocks, use the primary key mode to achieve the real-time update target, query latency for complex join just in second level. Here I'm going to show you some case study for another client, which is trip.com. Maybe you already know this. It's a very famous travel online booking website. The big data and the virtualization platform is used for internal analysis like user behaviors, and they deeply bonding with ClickHouse, which become a nightmare. Recently, with the data and the query increasing every day, ClickHouse cannot support standard SQL. The complex query have to run by manually. Cannot support high concurrency. CPU could be super high. Cache hit percentage is just around 10%. Cannot reduce the workload of cluster. Data import into two systems make it cannot guarantee consistency. Also double the cost of the hardware. The StarRocks solution solve all these problems. Currently, our real-time and offline scenario has been migrated into StarRocks. The average query response time just 200 milliseconds, less than 1% query higher than 500 milliseconds. Also, use a unified and simple OLAP system help to save huge cost of both people and hardware. Okay, that's all my presentation today. Question time.
Yeah, thank you, Peter, for the great talks. It covers quite a range of technical depth as well as the use cases.
Yeah.
So I know you're trying to jam everything in within hours, so speaking really fast. So any folks, if you have a question, so since we only have a few people, so if you want, you can just unmute yourself and ask a question directly. If you prefer, you can also post on the chat, and we can help you to ask the question. While waiting for others to think about their questions, and I probably asked a few, so so I have a lot of questions, but then as you go along, I kind of forgot what I was originally want to ask. So the many of the techniques that you described in your architecture, whether it's column partitions, or whether improvement execution plans, that seems like most of the other databases also adopting the similar plan. So I wasn't particularly sure where is your secret sauce in a sense, right?
Let me answer this question. The database system is not just one it's not just one aspect. It's include a lot of different aspects, like the high concurrency query, like the transaction support, like the hash table, distributed data, and the parallel execution engine, like the column storage, not just even a column storage engine, not just in disk, but also in memory as well. So it's combined with different aspects. Like for example, the CBO engine. A lot of different company doesn't have this CBO engine, but some of them, I know some of them they may have, but when they generate different plans, a different CBO engine will give you different results, right? So how to choose the best plan, and sometimes the user case is pretty important for us, because we need to grab the feedback from our client. They have the real data we don't have, and we help our customer to improve the performance, and we will study, or in this case, we need to push these predicates down. We need to push these operators to the storage engine to do more data filter, and we can do in this case, we can do co-located drawing without any network transfer. And this case, we should use the hash broadcasting without do any full network transfer. So a lot of things we did optimization based on the real world scenarios. So yeah,
that's pretty cool. And I always was looking for, when I was at a GoPro and managing the GoPro data infrastructure, as well as the analytics reporting, visualization, and also machine learning infrastructure. So I was looking for something like this to give the user like ad hoc reports rather than pre-built reports. So before I left, I was contemplating what the databases were to try to do. I think we initially tried a few different options and it wasn't successful. I was very interested in the use case you're talking about, the Airbnb's ones, because I know they have these analytics report systems, and which they even wrote 2 or 3 blogs about it. But I didn't really, it was powered by databases, StarRocks. So I always under the impression they were using Druid, Apache Druid, and with a super, Apache superset on top of it. And then so that was interesting.
I can let you know, like the cluster size inside Airbnb is very big for the Druid, Presto, and also the Elasticsearch as well. It's using like thousands of the server, but when they move to the StarRocks, it just use 20%, 30% of the server to replace.
Oh, wow.
So the cost is huge reduced. So
I see. That's actually important. That was one of my questions. When you when you say, hey, with this 10 billion 1 billion rows and that, and so what's the size of the cluster if you've got a lot of stuff in the memory? So all these clusters, do you require a lot of stuff loaded in the memories?
Yeah, we have our memory engine as well. Yeah, some caches, some of the especially for the primary key index. Yeah, we use memory to do optimize to speed up our search to more quickly scan the data and locate the data. So we do something like for example, the primary table model, we use the delete and insert method. Normally, other competitors use the merge on write or merge on read method, but we use delete and insert to optimize. So you can compare with different competitors. You can see in the real-time updates, we are more faster. So a lot of details like this we did. Yeah.
You have a paper who describing all
Yes,
okay.
It's all on our docs.starrocks.com. Yeah.
Okay, so maybe you can share the link because I can share with the folks.
Oh yeah, sure.
On the media feed. So people who still waiting their questions. If you have questions, yeah, post it. Yes. Oh, that's Peter. So that's a docs.starrocks.com. Anyone's online still have questions? I don't want to dominate questions.
This is Eric. Sorry.
Yeah.
This is my first time hear about the StarRocks.
Yeah.
So this sounds very interesting with a lot of optimizations.
Yeah.
I was just for the comparison perspective. I was curious how StarRocks compare with like RocksDB, Foundation DB, or Aerospikes on those for targeting for the high performance.
Yeah, I think the RocksDB, you mean the RockSet?
Yeah, RockSet. Yeah.
Yeah. I can tell you some details about the RockSet. The RockSet is more like a KV. It's more like a KV engine, and it's not a column storage. It has the column index, but it's still the row storage. So no shuffle join, no collocate join, and no external table in RockSet, which sometimes you need query the data, not import the data. It support the roll up, but no incremental update. So that means the incremental update will be really hard in RockSet when you create the roll up. No transaction support, atomicity not guaranteed. So when you import the data from like S3 or some other data source, sometimes it may interrupt. The query may be interrupt, and if you do a re-import, delete and re-import, that will be a huge cost. If you continue import, it maybe already have some data not correct. So the transaction support, atomicity support is really important for the data ingestion, and they don't have ORC files format support, which is pretty important for our customer like Airbnb. It's really more on failed index, more storage will be used. So it's really good product, but it's using more storage. Like if you have 100 GB data file need to import, they will use 500 GB for you. So in StarRocks, we do the columnar storage compaction. So it may be less than your the storage usage in StarRocks may be less than your original data size. So I mean the performance comparison is not the full view of the database. So you have to consider a lot of things, like the muti-table join, the external table access, the incremental update, the transaction support, a storage cost like that. So yeah, that's my answer.
Thank you.
No worries.
Yeah, that's an excellent question.
Yeah.
Anybody else that has a question, you can unmute yourself.